Tangram is a Chinese geometrical puzzle. 7 pieces, cut from a square, can be used to form various other shapes. Tangrams are great exercise in spatial awareness. Individual shapes must be slid, rotated, and flipped to form a new shape. Let us explore the use of Tangram as a teaching aid for some mathematical concepts. In this video, we will cover transformations, congruence, and symmetry. In the next video, we will cover perimeter, area, and fractions using Tangrams. Let's get started. Instead of buying Tangram from the market, we will create our own with a thick card sheet and a printout with a Tangram profile. We will explore A4 paper so that all students can perform these activities. Tangram puzzle is made up of 7 polygons or tans. Each piece is called tan. There are 5 triangles, 1 square and 1 parallelogram. There are 2 large triangles, 1 medium triangle and 2 small triangles. First graders are introduced to 2-dimensional shapes. Students get used to using the correct name for shapes as well as imagining how these shapes move and rotate through space. These puzzles are also an easy way to build vocabulary surrounding geometric shapes like triangles, square, and rectangle. We can make all kinds of different shapes with 7 tans. Basic shapes can also be constructed with 7 or fewer tans. Restrict the number of tans and ask how many shapes are possible with these tans. Construct squares with different number of tans like 1, 2, 3, 4, 5 and 7. Can we do it with 6 pieces only? Do analysis and find out why it is not possible. Make other shapes like triangle, trapezoid, parallelogram and polygons with more than 4 sides. Let us visit basic actions first. Transformations are changes that are made to a shape. Slide, turn, and flip are position changes you can make to a shape. These changes describe motions and the result of a motion. I can slide this triangle to the top, bottom, diagonally, to the left, or to the right. Slides are simplest transformation. Just moving something from one place to another. No rotation, resizing or anything else. Just moving. In pre-primary grade, children learn to describe relative position using words like above, below, and between. In primary grades, we usually describe a slide using relative position words such as slide to the left or slide down and to the right. Slides are also known as translation. In higher grades, we often use grid coordinates. So, a translation by 50 means to slide right 5 units. Translation by 0 minus 5 means slide down 5 units and so on. Minus 5, 4 means slide left 5 units and slide up 4 units. Just like we flip the paper, shapes can also be flipped. Let us use these 2 triangles. We will place one triangle on the top of the other. I can flip the triangle on the vertical side. This is the original position and this is the position after flipping. Flip triangle is the reflection of the original position. We can place a mirror on this vertical side and see the reflection as well. Same triangle can be flipped on the horizontal side like this. Again, it's reflection of the triangle. Try flipping the triangle on the longer side. Flipping is always performed with respect to a line. If we flip the triangle in this position with respect to the middle line, its orientation remains unchanged. Try the same activity with a square and parallelogram. You can also trace the shape on the normal paper with a sketch pen. Flip the paper and you see its image just like you flip the shape. A turn or rotation describes the motion of turning a shape, as if it were drawn on a piece of paper and you turn the whole piece of paper. The usual primary grade vocabulary is a turn and the usual middle grade vocabulary is rotation. Rotate the triangle clockwise or anti-clockwise. You can rotate it by full turn, 1/4 of a turn, or half turn. Triangle in this square can be rotated counterclockwise to form another triangle. Same triangle can be rotated counterclockwise by 45 degrees, 90 degrees and 180 degrees. With the help of grid lines, we can rotate the shape in steps of 90 degrees and measure the angle as well. 90 degrees, 180 degrees, 270 degrees and so on. Right now, we are rotating a triangle around one corner. But with the help of pushpin, you can rotate around any point on a triangle. Use a pen to trace various angles of rotation and build a nice design. Terms will change with grade. With primary grades, we will talk in terms of center, angle of rotation, etc. After any of these transformations, the shape still has the same size, area, angles and line lengths. Try these operations on other shapes and with different points around which you can rotate. In geometry, two figures or objects are congruent if they have the same shape and size. These two triangles are congruent as all corresponding angles are of the same measure, so are the sides. We can quickly check this by overlapping two triangles. Same is true with these large triangles as well. How about these two squares? One is a regular square, while other is formed with the help of two small triangles. We can place this square on the top of the square on the right and check if they are congruent. Yes, these two squares are congruent. If you have two sets of tangrams, squares, triangles and rectangles can be formed in different combinations, so that concept of congruence can be tested. In elementary geometry, the word congruent is often used for angles. Two angles are congruent if they have the same value. We can keep a small triangle on the top of large one and verify. Same is true for other two corresponding angles as well. These two rectangles have matching angles equal, but their matching sides are not equal. So, these two rectangles are not congruent. They are the same shape but not the same size. The two triangles on the left are congruent, while third is similar to them. the last triangle is neither congruent nor similar to any of the others. How about a mirror image? This triangle on the right is mirror image of the one on the left. Are they congruent? Yes, they are. Their corresponding sides and angles are equal. Triangles are congruent if you can slide them around, rotate them and flip them over in various ways. But if they overlap exactly, they are congruent. How about similar shapes? Similar shapes have different sizes but the same shape. Corresponding sides and angles are in the same proportion as well. Two homes side by side but different sizes are similar, but not congruent. Two squares of different triangles are similar. Similarity means to have the same shape. Congruence means to have the same shape and value as well. Symmetry can be better explored with tans made from A4 paper. Fold this paper to make a square. Cut with scissors and discard the rectangle. Unfold and cut square along the fold. We get two triangles. Take one triangle and fold it again in two equal parts. Two triangles are part of the 7 tans we will build. Let us take this last triangle and fold it just to get a midpoint on this long line. Turn around and fold it like this. Cut along this fold line so that we get a medium triangle. This is our third tan. Use paper tangrams to explore more about symmetry and its notations. When the folded part sits perfectly on the top, matching all edges, then the fold line is the line of symmetry. This square can be folded in different ways, such that the folded part sits perfectly on the top. This triangle has only one line of symmetry. If I fold it like this, two parts do not match. We can take help of the mirror as well to find the line of symmetry. When mirror is placed on the line of symmetry, the shape looks the same. Mirror can also be placed on the square on different lines of symmetry as well. Lines of symmetry can be identified and different formations of tan can be tried out with student as well. Do try this at home. Templates of Tangrams are available for download as PDF files in the description or on my blog at textbookscience.blogspot.com. Thank you.